All right, hello students, Mr. Silber here, and we are going to do an experiment, a scientific investigation called Signs of a Chemical Reaction, and we're going to be dealing with sodium carbonate, magnesium sulfate, sodium bicarbonate, and then calcium chloride. The first thing we need to do is we need to take each one of these cups, and we take our cabbage juice. So this is distilled water, and it has cabbage juice extract in it from a red cabbage. So I'm going to be mixing 50 milliliters into each one of these cups. We're going to start off with sodium bicarbonate and cabbage juice. So sodium bicarbonate is this, and we're going to measure out 50 milliliters of the red cabbage juice distilled water solution. So here we go. To 50 milliliter mark. And you always want to hold this nice and level when you're measuring. If you need an exact measurement, it's best to put it on the surface. So here we go. Let's go ahead and pour this in. And you should see a green color. So let's stir. Try to dissolve. So it went from a light purple color to now it's a kind of a green or a teal color. And oh, it does feel cold. So that cold temperature change tells me that this is an endothermic reaction. There are two types of reactions when it comes to temperature. There are reactions that release energy, and there are reactions that absorb energy. So this is absorbing, and that's what gives it the cold temperature. So it is cold, and we did have a color change from purple to green, so you can update your table. And I'm going to waft it in my nose to see if there's a smell. I don't notice any odor, no gas produced. I also don't see any bubbles, like a sign that there would be gas. Okay, so let's move on to the next one. All right, the next one we have sodium carbonate and cabbage juice. So let's go ahead. We're going to measure out 50 mLs, 50 milliliters. Okay, let me double check. That looks pretty good. So here we go, sodium carbonate plus cabbage juice. In we go. Okay, and right away I'm feeling a warm temperature. So we've got an exothermic reaction going on here, and we also have a light green color. Looks like the green color is kind of starting to turn yellow. This is actually getting quite warm. And let me waft for, doesn't smell like anything, and I do not see any bubbles. And I do not see any precipitate. Precipitate is It's not like precipitation. It does sound like it. But precipitate is when you have a solid forming out of two liquids. So if I were to combine two liquid mixtures and a solid began forming, that would be called a precipitate. So this actually changed from green and now it's yellow. Interesting. I'm going to have you fill these in for each one based on my observations. And if you need to rewind to get this data again, you can do that. We're going to move on to calcium chloride and cabbage juice. So here's the calcium chloride in these beads. We need 50 milliliters of distilled water with cabbage juice extract. And I'm holding this level. Okay, that looks good. Here we go, calcium chloride plus cabbage juice. Get a spoon. Okay, and we have another, looks like similar color, greenish teal for the color change. It is getting warm, so temperature change. It's actually getting quite warm. This was originally about 70-degree water. And this one's getting the warmest. If I put a thermometer in here, I bet it would read about maybe 40 degrees Celsius, and originally it was about at 20 degrees Celsius water, 70 degrees Fahrenheit. So this is actually getting quite hot on my hand. It might even be around 50 degrees Celsius. No gas produced. Let me waft. And when I say waft, I'm doing a motion like this, wafting it in my nose. You never put it directly over your nose, because it could be dangerous to do that. So I don't smell anything and I don't see any bubbles, but there was a temperature change increase. No precipitate, but there was a color change to green. All right, and the last one, magnesium sulfate, right here in your table. So let's measure out 50 milliliters. And here we go. Okay, this is staying purple, kind of keeping that same color from the cabbage juice extract. And this feels just slightly cold, just a little bit of a temperature decrease. So this would be an endothermic reaction. And I don't, here it is to compare. So they look pretty much the same in color. So I do not see a color change. I do not see any precipitate. And I do not see any gas. Do not smell any odors. So this one seems to be only a temperature change. Temperature, it got colder. All right. So moving on to our next part. Try to get all of these in view. And I'm just making sure these are dissolved. So now we're going on to this part, this table. So in this section, we're going to use the test tubes and we're going to use the pipettes. Okay, and we're going to actually start mixing these together and seeing what happens. So the first one, we're going to do magnesium sulfate plus sodium carbonate. All right, and we'll be looking for color change, temperature change, gas produced, precipitate formed, or precipitate formed. All right, so test tube A, and we're going to fill it 1/4 of the way full with one solution and the other 1/4 of the way with another solution. So first one is magnesium sulfate. And that's this one here. So we're going to fill it 1/4 of the way full. Okay, that seems about right. And then the other 1/4 of the way full, sodium carbonate. We want to make sure we keep all of our pipettes and spoons separate because we don't want to mix them unintentionally. All right, let's see what happens. Okay, so we have what's called here is a precipitate. So we had two liquids combine. Let's see if I can get it. And that cloudy substance is actually a solid. Crystallines. So precipitate. Do not see a color change. We feel. Don't feel a temperature change. Don't see any bubbles or gas produced. So this one, magnesium sulfate plus sodium carbonate, just noticing the precipitate formed. All right, let's try the next one. So now we're right here, magnesium sulfate and calcium chloride. So here we go with the magnesium sulfate. Fourth of the way full, and calcium chloride. Get that pipette as full as I can. Okay, here we go. All right. So it looks like another precipitate. This one, like, there's hardly any liquid left. Like, I could turn it upside down almost. So lots of precipitate formation. No gas, no temperature change, no color change. So that was for magnesium sulfate and calcium chloride. Okay, next one, magnesium sulfate again. And sodium bicarbonate. Sodium bicarbonate. This one does not want to dissolve all the way. I'm going to stir it up and get my last clean pipette. Sodium bicarbonate. All right, here we go. Okay, this is cold to the touch. Endothermic reaction happening. I do see bubbles. I see gas being produced, if my camera will focus. So we have a temperature change, temperature decrease, and we also have a gas being produced. See the bubbles rising. Don't believe we had a color change. Maybe a small color change. It was originally green, but now it's pretty much clear. So went from green to clear, but we definitely have gas being produced, and we have a temperature change, decrease, getting colder. All right, last one, we have calcium chloride. And sodium bicarbonate. Here we go. Oh, look here. All right, so wow, look at that. Lots of gas being produced, lots of bubbles. It is overflowing. And let me see if there's a temperature change. Maybe slightly warm, maybe. So we'll do just slight increase in temperature. So any color change, we had calcium chloride, which was yellow, and sodium bicarbonate, which was green, but now it's just white. So I guess you could say, yeah, color change from yellow and green to white, and no precipitate formed, just gas produced and a very slight increase in temperature. Okay, so you should be able to fill this table in for this last column, evidence of a chemical change. I gave you some notes about how you can tell when a chemical change is happening, and you need to look over those notes. So there are physical changes, physical reactions, and there are chemical changes, chemical reactions. And you need to decide if these were chemical reactions or chemical changes, and use your notes to determine whether these changes were evidence of chemical change or not. All right. And that's all you need to do. That's all we were able to get done today. All right, I'm going to sign off of here, and I'll see you all later. Bye-bye.